Warning: chemistry is extremely dangerous. It involves the use of highly corrosive chemicals, strong oxidizers, and noxious gases. Please do not attempt to recreate without the proper background, knowledge of all chemicals involved, and safety precautions.
Today's subject,
Chemistry.
and freedom.
Aspirin is an over-the-counter medicine from the salicylate group, which has benefits such as pain and fever relief as well as managing inflammation. But I want to make a mint flavoring from it. The flavoring I'm making is known as wintergreen and can be naturally derived from the wintergreen plant, but also is commonly synthetically made. Being a salicylate, it has use in pain relief creams such as Icy Hot, but is also used as a flavoring because it turns out mint just tastes good. For this reaction, I'll be performing a Fischer esterification and a trans esterification. One section of the molecule will have a new carbon chain added to it, while another is going to have its chain replaced with an alcohol group. This whole thing's kind of inefficient, but it's also the fastest way of doing it. To start, I poured 25 pills from a partially empty bottle into a beaker. I then counted off 50 more pills from a second bottle into the same beaker. These luckily weren't gel capsules, so I didn't have to embarrass myself opening them again. To crush the pills, I used a blender I found in the garage. I made sure to clean it up and everything, but this blender is actually older than I am. I poured all the pills into the blender, then pressed the liquefy button until the pills were completely powderized. It also turns out that breathing in the powder hurts your lungs a lot more than you think it does. Once that was done, I poured the powderized aspirin back into the same beaker. I then added about 200 milliliters of methanol. Afterwards, I put the beaker on a hot plate, added a stir bar, and turned on the stirring. I left this for about an hour so that the aspirin would dissolve in the methanol, but leave the binder and other things I didn't want. After everything was dissolved, I poured the solution through a coffee filter into a 1 liter flat bottom flask. The solution was a bit cloudy, but it wasn't really enough to hurt anything. I made sure to wash the beaker and the filter with a bit more methanol just to make sure I got everything. I placed the flask on my hot plate with strong stirring and then began to pour in 25 milliliters of 98% concentrated sulfuric acid. This needs to be done really slowly with strong stirring, or else it could get too hot and boil on its own, which is really dangerous. You can hear it bubbling and see the vapors start to form when I pour it in. Something really interesting about aspirin is that it's a blood thinner, which means it can help alleviate heart attack symptoms. And studies show that 90% of heart attack victims are self-conscious of the way their breath smells. So since you'll have aspirin lying around, it's important to know how to turn those pills into mint, so it's really important you're paying attention. After I finished adding in the acid, I turned on the heat and set up a reflux condenser. This allows the methanol solution to boil and carry out the reaction without losing any of the vapors. The water in the column's ice cold and condenses the vapors before they can escape out the top. While that reacts, I can explain the mechanism of the two reactions that are taking place. In this reaction, the methanol reacts with the aspirin in two different ways. It reacts with the carboxyl group at the top of the aspirin to undergo a Fischer esterification. This means the oxygen and carbon group on the alcohol will replace the OH group. The acid catalyzes this by donating a proton to the alcohol, which is then picked up by the carbonyl oxygen. This stabilizes, leaving a spot for the oxygen on the alcohol to bond to the carbonyl carbon. The excess alcohol then picks up the hydrogen from the newly formed methoxy group. That extra hydrogen on the alcohol is picked up by one of the alcohol groups on the initial carbonyl carbon, which is kicked off as water. The remaining alcohol forms a double bond with the carbon, which kicks off its hydrogen to the alcohol, forming an ester and the required starting material to continue the reaction. The other reaction is a trans-esterification, where the acetyl group that makes an ester on the aspirin is removed and forms a new ester from the methanol. It's catalyzed in a very similar way to the Fischer esterification, but instead of creating a new ester from a carboxylic acid and an alcohol, it swaps the alcohol and ester groups of two molecules. In the diagram shown at the top, methyl acetate would be the newly formed ester, while the alcohol group is now part of the wintergreen molecule. If you want a different but not as in-depth example of this type of reaction, be sure to check out my benzocaine video. After letting that reflux for about an hour, I transferred the solution to a hot plate in my fume hood. I did this because I needed to boil off about half the methanol volume before the next step. Methanol is very toxic and metabolizes into formic acid and formaldehyde in your liver. This will be important later. I wiped off the mess that was made from me spilling the solution everywhere, but you'll see there was no point. Yeah, I don't really know what this is. It's the same thing as as the methanol when I dropped it, but I think I just sprayed it everywhere with this really strong stirring, cause it's just a mess. But it's not on the inside of the beaker. So my stuff didn't get scorched, but on the outside I just made a big ass mess. I don't know what's going on. While that boiled off, I just sat in a chair on my phone and watched the methanol go down. Once it got down to about 100 milliliters, I took it off the hot plate and let it cool just enough that I could hold it. I then poured the still hot solution into a separatory funnel which contained ice cold water. This caused the unreacted material to crash out and float to the top while the wintergreen sank to the bottom. It was about this time it hit me that I'm smelling the mint flavoring a lot more than I should. And you guys remember what I said earlier? Methanol is very toxic and metabolizes into formic acid and formaldehyde in your liver. Well, I kinda messed up. Yeah, I have it so my fume hood blows out a window, but I didn't even open the window. I let methanol vapors blow back into the room I was chilling in the entire time. It turns out I'm fine, but that was probably the most dangerous lab mistake I've ever made. It was finally at this point, right after shaking the funnel, that I actually opened the window. Once the layers were fully separated, I drained the lower layer into a small beaker and discarded the upper layer. I washed the funnel and poured the wintergreen back in, followed by a saturated baking soda solution. This is because the products can still be highly acidic from the sulfuric acid. After adding, I shook the funnel to mix the solutions, vented it to let out the CO2, and then let it separate. Once that was done, I drained off the lower layer again and repeated this 2 more times. After the last washing, the wintergreen was still really cloudy, so I added some anhydrous magnesium sulfate to absorb the water. I then filtered it through some cotton, but it didn't really filter like I wanted it to. So I packed the funnel again with some more cotton and even more magnesium sulfate. This helped get it a bit more clear, and it had a final weight of 5.2 grams, which was about a 25% yield, which is kind of expected. This video was a lot of fun to do, and it made my entire lab smell like it was full of nothing but stacks of mint. And I'm sorry for the long delay, there were a few hiccups, but I should be back to normal. If you've watched this far, why not subscribe? Me almost poisoning myself has to count for something.